How's everyone doing? You guys here learn more about Einstein Platform Services, Einstein Language, Einstein Vision? All right, let's get excited. It's the afternoon. We got the lunch doldrums happening. I'm Michael Machado, Director of Product Management for Einstein Platform Services. Pretty excited to talk to you guys about what we announced today in Einstein Language. Saw it at the keynote and live in action. We're going to go through a little bit more in depth on everything today, though, through this presentation, show you it live, show you it running on our production stack, and also get to show it integrated within CRM. So it should be pretty exciting. As a, see if this button's working. You want to give me a click? Always know we're talking about forward-facing products that are not always GA right now. Einstein Vision is for image classification, but Einstein Language isn't. So please make buying decisions based on what is currently GA. And that's all the legal speak I got.
Cool. Thanks. Hi, guys. I'm Zina Baraki. You guys can call me Z. I'm the product manager on the Einstein AI team with Michael here. Half of our team is top data scientists that are advancing the state-of-the-art in computer vision and natural language processing. And then the other half of our team basically leverages these breakthroughs to deliver you guys products. So today what we're going to cover is really show you how easy it is to embed deep learning models into your applications. So whether those are Salesforce workflows or external applications. We're going to talk about deep learning and how it can unlock business value, so solving complex problems that we couldn't before. And we're going to talk about our deep learning service APIs, so Einstein Vision and Einstein Language. We're going to show you how to build your custom model using these APIs, and then how to integrate those within Salesforce CRM workflows.
Great.
So do you want to talk about deep learning?
Yeah, you got it.
Yep, got it.
So deep learning, we've all heard about the AI revolution. We're all getting told that AI is the next big impact that can happen on my business. And it's really being led by three major components. And we're going to walk through these very quickly today, but we do want to give some background into why we think this is a huge opportunity for all of you trailblazers to start adopting these services. So data, big data in general, has been a topic for the past 5+ years. Everyone's excited. We have new sources of data, new ways of analyzing it, new ways of storing it. This is going to be a big proponent on how we bring artificial intelligence into the enterprise. But a lot of our effort has been on the algorithm side. These are complex algorithms that are being built upon and expanded, and actually having new research from private and public sector, ensuring that these algorithms are going to be continue to innovate and continue to drive new features for your applications and your customers' experiences. And then finally, compute. GPUs, TPUs, new investments, new research from NVIDIA. All the best hardware companies are going towards compute power, ensuring that these algorithms have the infrastructure they need to continue to be innovative and be able to drive insight for you. Now, there's two forms of structured data. I was thinking about that data, that first component I mentioned. We have structured data. This is your ERP data. This is majority of your CRM data. This could be structured data coming out of IoT devices. There's a lot that we're thinking about at Salesforce about how to deliver capabilities for our developer communities to leverage that data and build smart apps from it. But the majority of our topics today are going to be on the unstructured data side. How can you use image data? How can you use text data from your structured, from your case descriptions, your case subjects, to start to gain insight, gain a competitive advantage? Because a lot of this data wasn't analyzed historically. And the reason being is we really didn't have the machine learning algorithms there to support this. So machine learning, traditional machine learning was great on structured data, but deep learning has really shown leaps and bounds improvements on the unstructured data sources. So image recognition, for instance, just 5+ years ago, was sitting right around 70+% accuracy, not really enough to drive huge value for a business and really bake it into a current business process. Within the last couple of years, we've seen that jump into the mid-90s, surpassing human accuracy and doing image recognition. And that's really what's going to drive innovation continue going forward. So our ability to understand these unstructured data sources give us an opportunity to really build new apps that change the way our companies run. And I think every new app that's built in the future is going to be relying on artificial intelligence and including unstructured data as a major way of building applications. So I've mentioned deep learning. We'll take a second. It's a complicated term. A lot of people get overwhelmed. They think, okay, I don't have the GPU infrastructure to handle this. Neural networks, I need a PhD to really understand what is state of the art, which model should I be incorporating. And we try to break that down to a much simpler thought process for you guys. So you're able to start thinking, okay, I've got input A. This could be an image. This could be text. This could be audio files. And I want to derive insight output B. And that's how we were trying to simplify the APIs that you use from us to make this process really seamless for you. So you've got, a good example would be I've got an image, and I'm trying to understand the object that I need to identify in that image, or my brand that I want to identify. I've got a text file, and I want to translate that into English text file into French. Or I've got an audio file, and I want to go audio file to transcription in English, or English transcription into audio file. All of those use cases that drive image recognition, that drive natural language understanding, are going to be built on deep learning platforms. And so if you want to build this workflow automation into your systems, this is the place to be. This is the talk you want to be hearing about, and so I'm excited to talk about what innovations we're delivering for you now.
So who doesn't want to automate workflows, right? Every business wants to build in artificial intelligence into their applications to be able to, solve complex problems and solve their business needs. But this has been traditionally very hard, right? You need a team of experts that are going to build your models, fine-tune them, manage them once they're deployed. You need specialized infrastructure, right, to be able to even deploy these models. And then you need to keep up with your compute needs, your scalability needs. And then you also have to keep up with all the algorithm advances. But have no fear, Salesforce is here, and we're making it very easy for you to embed deep learning into your applications. So how do we do this? Well, first, we provide a hosted infrastructure. So we really manage your models as a service to meet your scalability needs. So we make it very easy for you to upload, train, as well as understand your model metrics. We provide predictions in real time, so whether that's on pre-trained models that we provide or on the custom models that you build. Secondly, it's built for Salesforce, so on our trusted platform. For the CRM use case, our models are optimized for sales, service, and marketing. And finally, as we mentioned, we're leveraging our internal sales team to really bridge the gap between research, engineering, and products that you can use. So let's take a look at specifically one of our deep learning services, Einstein Vision. So just a little context, not all deep learning models or neural networks are created equal. Specific architectures are used for specific problems. In the case of computer vision, we use what is called a convolutional neural network, which by definition means that each layer learns from the previous. So in other words, learnings are passed from one layer to the next. So when a convolutional neural network is trained on image data, it rebuilds the image from the ground up to understand its different components. So if you input an image, it'll first look at its smallest unit, so the pixel, and then understand the edges, and then the next layer will understand object parts, and then eventually objects. So with this, you can think of different use cases that you can solve, so image recognition, object detection, etc. So you might ask, why does Salesforce care about computer vision, right? So there's 1.2 trillion images that are going to be taken in 2017, and that's because we're all carrying phones around with us. But you can also think of other image sources, right? Security cameras, satellites, etc. And it's the new way that we communicate and connect. And with computer vision, you can unlock business value with that. So you can think about how you can transform the transportation industry by using drones to monitor highways and know when to send a cleanup crew. Or how CPG companies, instead of sending individuals to manually record the products on a shelf can just take a picture and have it automatically analyzed, or how consumer retail can be revolutionized with like visual search, or how insurance companies can automate triaging of claims, or how image processing can be leveraged by healthcare. And so that's why we've launched Einstein Image Classification, which is currently GA. So this is available for you guys right now. It makes it very easy for you guys to build your own custom models and then integrate these within your workflows. So whether that's a Salesforce workflow or an external application. And currently, we have customers that are using this for visual search, so redefining how customers are looking for or discovering their products. Brand detection, so monitoring of social media, as well as product identification, so streamlining sales or service processes. So let's take a look at how you actually build your own custom model. So the first step is defining what you want your model to do. So for example here, I want to be able to tell the difference between 3-door refrigerators and 2-door refrigerators. So the first step is to collect a bunch of images of 2-door refrigerators and put them in a folder, and then a bunch of images of 3-door refrigerators and put them in a folder. And then I'm going to zip those, upload them, make a call to train, and then I'll get a model ID. And with that, I'll be able to use it to get predictions on images that the model has never seen before. And I'll iterate, use my model metrics to improve my model, and once I'm ready, I'll embed this into an application. So let's take a look at what these API calls actually look like and how this actually works. We're going to build a model here together. So I have a data set here that basically looks at flat houses, so houses with flat roofs. So I have a bunch of images here. And then I have a bunch of images of pitched roof houses. And I've zipped these together. So I'm going to Postman here, and I'm going to upload these. So I'm going to select the file, which is basically just these folders that are zipped together. And I'm going to upload it. And I'm going to get a data set ID. And when I get my data, we're still uploading the file here. You'll see here in return, I'm going to get a data set ID. So this data set ID is what I'm going to use to train my model. So next thing is I'm going to make a training call. So I'll enter this data set ID. I'll enter a model name. And I'll say, go ahead, train. And this usually takes a few minutes. I get a model ID. But it takes a few minutes for the model to fully train. So I'm going to copy this model ID and look at my model metrics. For the sake of time, we've done this before. But you'll see here that the first thing is that the labels for my models are basically the names of the folders that I used. You'll notice that I get an F1 score. And I also get test accuracy and training accuracy scores. We basically keep 10% of the data that you upload, and we use that to train your model. And then you get a confusion matrix, which you can use to continue tweaking your model, iterating on it until you're happy with it. And then you can integrate this into an application. So let's test this out. Let's see what it looks like. So I have here an image of a roof, of a house that the model has never seen before. In this instance, this is a flat house. So let's get a prediction from the model and see what it thinks. And it correctly predicts here that this is an image of a flat house. We can try one more image. We have an image here of a pitched roof example. So let's try that out. So you can see this image is a pitched roof. We'll just click send. As you can see, you get predictions within seconds. And here again, it predicts this at pitch. So now let's take a look at what that would look like integrated within a CRM workflow. So let's imagine that I'm a sales rep for a solar company, and these are basically all of my leads. And you'll notice that there's different sources of leads, whether that's social media, on the website, etc. I remember from the trade show, Annie Blitz, actually, and I noticed that her lead score is a little lower than I was expecting, right? So let's click into the details here to see what might be going on. So the great thing with Einstein lead scoring is that it's not a black box. You get the details as to why the score is what the score is. So you'll notice that the roof type is unknown. And so you can also see that the address is valid. So what we can do is leverage Google Maps to find the house, and then use the model that we just built to analyze the rooftop. And you'll notice now that the lead score has been updated to 92. So we walked through this manually, right? But you can imagine how this can be automated and how you can now augment lead scoring with image classification, for example. So I've walked you through now how to build your custom model using Einstein Vision and shown you how this can be integrated within a CRM use case. And Michael's going to do the same with Einstein language.
Thank you.
Of course.
I had this working for a second. Let's see if oh, there we go.
Oh, I did that. No worries.
Let you have it back.
Yeah.
Great. So hopefully, if you guys have signed up for Einstein.ai already, you got an email this morning announcing the great announcement around Einstein language being open beta for all current users of Einstein Vision. If not, hopefully you sign up as soon as you leave this presentation. But we're really excited to talk about Einstein language today. I'd like to start kind of from the bare bones, understand the algorithm that we have in place here, help you guys get an understanding of why each neural network architecture is slightly different to solve the problem you have at hand, and how we try to obfuscate that from you as the end user. So in this case, we have a recurrent neural network. As we start to think about natural language, it's very different than images, right? Images, we are able to build it up from the ground up, each layer passing on in the weights and the information across each layer of the neural network. In recurrent neural networks, we actually want to have the ability to consider the context, not just before I've seen that word, but also after I've seen that word. See, the ability to have that not just be pre-weighting words, but actually have the complexity of the English language, how the words around it influence words, really lends itself to a recurrent neural network as being the preferred architecture. And we're going to leverage this architecture, delivering 2 new features for you guys that are available for you guys to start playing around with right now. Einstein Intent, which is a natural language processing kind of general classifier that allows you to define your own classes, upload data that represents those classes and the utterances you'd expect those classes to be in the future once you're in production, and train a model. And we're going to do that in just a second. But also Einstein Sentiment. And Einstein Sentiment is a pre-trained model. We're able to analyze human language to derive the feelings or the context around a user's statements and classify those into positive, negative, and neutral classes. And the beauty of our models, as you train these and you make them smarter over time, is you can retrain even our global models for sentiment to actually make them domain specific for your industry. And we're seeing customers get already interested in this as we started talking about what we want to do with Einstein language, about enhancing their lead scores, about identifying kind of the sentiment, understanding if it's trending down or up, what the likelihood of the close is. Service cases, using this for prioritization, for routing, and marketing. If I have a new campaign that goes out, how can I understand user interest in that campaign or that product that just got announced in an optimal way through these Einstein language services? So just like we built image classification models, we're going to do the same thing for intent. We're going to define the classes first. In this case, I'm looking at intent maybe being about a routing case where I want to take every time a case description comes through, I want to analyze that and route it to either the shipping department, the billing department, product sales. Could be anything that you guys define. Same thing for sentiment, but instead these classes are fixed for you. So we have positive, negative, and neutral. And if you want to enhance that model for your own business and keep that model just for yourself, you can add data to this as long as it fits into those classes. After that, you go through that same automated steps where you can actually go through, you've gathered your data, you've supplemented these classes, and now you want to actually train your models. Training your models is very easy with our APIs. Once you've got your model trained, you'll have that model ID, just like we did with Vision. And you can integrate that REST API into any application, whether that's a legacy application, a Salesforce app, or even a net new application you're building for your users. So I like demos more than I like slides, so let's jump into a demo. Instead of doing Postman, we're going to go through a little bit of a simple UI I built. Because we've kind of walked through those steps of data gathering, data training, data prediction, we're going to skip through those and show you the prediction side of Einstein language. Now, sentiment has a model called community sentiment. You can go through our documentation, extract that model ID, and use that across any of your apps. And we're able to now put in free-form text into this that the model's never seen before and analyze the sentiment on this. So to give myself a little pat on the back, this demo shows that sentiment is a very powerful solution. Pretty strong signal in those statements, right? We've got powerful, we've got solution, we're excited about this, and naturally we classify this as 87% positive statement. But because we don't want to give ourselves just easy ones, let's take a little bit more difficulty, because I'm going to rag on Zineb for doing a demo in Postman. Watching a demo in Postman is like watching paint dry. It's a little bit of a sarcastic statement. I don't have any strong signal. If I was just weighting words and trying to, essentially take an average of the weighted words here, I probably wouldn't get a very high probability of guessing that this is a negative sentiment. You'll see our model performs quite well and is able to take more complex language structures and still be able to do a pretty good prediction here. Finally, let's take an example here that I think you can never get perfectly right, which is your air conditioner is literally the hottest product on the market. So I put this out, and I get this feedback coming in on maybe one of my message boards. Einstein Sentiment tells me this is positive. What do? I can't use this tool anymore. It's not right for my business. Well, the beauty of our models is you can go give us supplemental data and branch this global model off for your own custom model that only you can leverage. Your data secure, trusted in the Salesforce environments. But now you've got your own production model of an air conditioner business and how hottest means to you, because it's very different than the average customer or average company for how you define the word hottest and how it applies to your business. So that concept of retraining models, so it sounds kind of complicated, and it sounds like something that I'm going to have to go through a long, tedious process of getting data, reformatting it, hosting it in some infrastructure. We try to simplify that to you. So you just think column A are my unstructured utterances, the examples I imagine in production my users are going to say to me, and column B are my outputs that I want the model to create. So if this was sentiment, this would be positive, negative, and neutral. But in this case, we're using intent classification. So I've got billing, password help, maybe the most common cases I come through my service department, and I want to be able to quickly get them in the best agent's hands, prioritize them, predict a macro, and automate a response, or just ensure that the right department is handling the right case at the right time without having to pass through multiple hands. So if I train this model already, and now I'm going to use this Einstein API playground to show you it in action. So a simple example here would be, I'd like to update my purchases shipping information. Please help me. If I was word counting here, I'd probably say this is a shipping info problem. I got the word shipping and information here. They probably want some help. But really, I'm trying to make a change to my current order. So in the context of this business, it's actually an order change. It needs to handle, maybe if it's in flight, I can't do the order change. I might need to do a tracking number lookup to understand what processes can be put in place. So having the ability to do automated NLP capture right here is pretty powerful. Let's take one more example. What is the status of my shipment? Here, in this case, I can extract the tracking number for a customer, automatically tell them the status of their order, whether or not it's in flight, whether or not it's already been delivered and there's been a problem, and try to move this process through a lot quicker. Let's take one last one here. The most common service case across any of Salesforce customers, and likely everyone here standing here, if you work in a service department, is password reset. It's not really a major issue that you actually have to spend a lot of time to do, but you need to reset their password. How can I actually start to derive that insight? Not every time they use passwords, sometimes it's an account problem. In this case, this is awful. My password is locked again. Here we automatically are pretty confident here that this is a password help issue. We might even have a way of automating or gathering one piece of information from the user to get verified information and then reset their password for them. So let's look at how you could actually integrate this into a full flow. So I've got a web chat. Let's pretend my website, someone gets locked out of their account. I immediately pop this window out, ask them if they need any help, and they respond with that comment we just saw. I can now jump to my cases here. Look at my open cases. And as you can see, it's 424, so we generated a new case. If I click on that case number, I can get a ton of insight from this. So I've got a queue I've created for resetting credentials. Anytime I've got a password reset issue, I want to automatically reset that credentials and not make that customer wait for an agent and wait 10 minutes just to get their account logged in, get them into maybe a shopping cart and buying experience. I also know this has negative sentiment. So if this was a case where I needed someone to actually get on the phone with them, I know that this is kind of trending in the wrong direction for my customer experience standards. I might set a threshold under 65% negative and make sure that I either prioritize that or get in the right agent's hand who knows how to handle that case, who can solve that problem as quickly as possible for our customer. And the final thing here, if we go to our sentiment dashboard, I think this is really cool. So we're going to start coming up with new ways to visualize this data for you, so that way you can see trends over time. So if we could pop that little window up, and I send this again, in real time, we're scoring this, populating it in our sentiment dashboard. It's real time, so we'll see if it wants to cooperate with us. We're able to actually track trends over time and be able to understand. Try it one more time to send. Click on it. There we go. There's the population. So able to track trends over time, be able to drive insight here. Maybe I want to monitor my community board, see if something's trending down, what caused it, or I have a new product announcement, how's it being received. Having this dashboard of insight, understanding human emotion, and not having to actually ask them to explicitly tell you through a CSAT score or another mechanism. Really just let them express themselves in the normal context they give, and be able to understand that is a pretty powerful solution moving forward. So I hope you guys have seen the power of deep learning. This is just the beginning for us. The Einstein Platform Services, Einstein Language, Einstein Vision. We're going to continue to deliver new solutions for you that you, as developers at Salesforce, you can leverage. You can augment your lead scores, improve them over time. You can streamline your field service operations, automate the way you route cases, and build self-service communities. So your community can now become a place where people can not only help each other out, but automated agents can help ensure that people have a quick question, a quick answer, a quick KB article. You can surface it to them in the right time and really change the customer experience altogether. So we got a ton of stuff around TDX this year. We've had campfire sessions about best practices already. We've got booths over the left wing. Right when you jump off the escalators, you'll see further booths. I hope you guys take advantage. Talk to some of our engineers that are staffing those booths to learn more about these services, ways they can be implemented, things you should be thinking about when you're training your models, testing your models, and go through this process. Hopefully, let us know. Sign up for the service and let us know what you think.
Yep. You can sign up on Einstein.ai. It's free. You get access to both Einstein Vision and Einstein Language. Einstein Vision is GA, so you get 1,000 free predictions per month, and Einstein Language is in beta. So yeah, go ahead, sign up. Let us know. We'll be around if you guys have any questions. We actually have about 2 minutes, so maybe we can take a question.
Take a couple questions. Also, feel free to go into the success communities. We have a success community page that you can link to from our docs where you can ask questions about our service, any problems you're having, and we'd be more than happy to get to you on the success community as well.
Yep, go ahead.
Shout it out. Will Salesforce be productizing the case sentiment routing thing? I think we do think about ways we can integrate these APIs into our end services, but right now there's no product plan to do case sentiment routing at all. So I really hope that you guys can help kind of chart our path, and if you guys can build these custom apps, you guys can tell us how you think these services can be leveraged. So right now these APIs are made available to you guys to help kind of guide us and tell us what you need as feedback to make them better. Yes?
If you have historical millions of records,
yep.
So what are the best approaches to create that data set?
Great. So if you have millions of records, which I know some of you guys do, you've been Salesforce customers for a long time, what should we be thinking about as best practices to start generating these initial data sets, uploading them to our servers? Where do you want to start? What's a good number? I always think look at your most current data, because that's probably going to be most relevant to your business. Leverage that data as well as whatever you think are going to be strong inputs to that reflect how you see it being implemented in production. So if you have historical products that customers don't talk about as much, might not be as relevant as your current portfolio of products. Start with a couple thousand utterances per class and see how the performance looks like that. If you see a wide variety of utterances, you can add more and more data. We don't charge you on how much data you upload to our service. We don't charge you on how many models you create. Our Einstein vision classification model is only monetized based on predictions, and we expect to have kind of very similar pricing and packaging structures for language as well. We do have limits of 1 gig uploads per upload, so you'd have to stage it in multiple gig uploads. So it's always easier to stay within that, first upload being sub 1 gig to just make that process easier for you. All right, I think we are at our limit, but we're going to stick around.
Yeah, we'll be right here. If you guys have any questions, feel free to come up to us. We're happy to answer them.
Thank you, guys.
Thanks.